Good morning all. Today I'm going to look at this. It's Ino's box kit, electronic devices, burglar alarm, detect unwanted intruders, as opposed to detecting wanted intruders. Is there such a thing as a wanted intruder? Yeah, I can think of a few people who I would quite like. Anyway, that's another issue. Now this Ino's, I'm trying to work out what this means. Is Ein a reference to Einstein, possibly? Or is Ein simply just the German for one? Ones and zeros? I mean, there's nothing digital in here. In fact, this is decidedly analog, this thing. Now, I picked this up a couple of days ago at my local charity shop for 50p, which I thought was reasonably good value. Let's have a look. Build your own burglar alarm. In this box kit, you will find all you need to understand and set up your personal alert system. 2 AA batteries required. Do not mix old and new batteries. Not quite sure why they say that. I mean, okay, the old battery will run out before the new battery and could go to 0 volts, could even go to a negative voltage, but, well, so what? Do not mix alkaline, standard, carbon zinc or rechargeable nickel cadmium batteries. Why not? What's wrong with mixing them? In fact, I'm going to deliberately mix alkaline and rechargeable batteries because I can. Ino's exclusive circuit board, and that is distributed in the UK by Cheatwell Games. Yes, well, let's see if we are going to be cheated. Made in China. What else does it say? Aha! In it, it's got a capacitor, a choke coil, circuit board, connecting wires, cotton thread, a piezo transducer, resistor, and transistor. Warning, blah, blah, blah. Caution, contains functional sharp points on electrical parts. Functional sharp points, that's been translated. Non-rechargeable batteries are not to be recharged. Rechargeable batteries are only to be charged under adult supervision. New and used batteries are not to be mixed again. Only batteries of the same or equivalent type are recommended to be used. I'm going to mix batteries. I've decided. Right, let's see what we get inside the box. We get a book. Actually, quite a thick, detailed book with lots of instructions. Oh, very complicated numbering type instructions. An explanation of what everything does. A conductor is a material that allows electricity to flow quite quickly. What do you mean quite quickly? Choke coil. This device changes the voltage of the electricity flowing through it. What? No, it doesn't. That's absolutely not what a choke coil does. I mean, the explanation generally given for an inductor is that it resists the change in current flow. Not that it changes the voltage of the electricity flowing through it, unless, of course, you're talking about a transformer and you're talking about AC. That's very misleading. Also, we have this Professor Ino's Science. Ino. Still think it's probably more to do with Einstein than ones and zeros. Product catalogue. Wow, what have we got? All sorts of things here. Aquatics, Aviation Explorer, Nature, Galaxy, Dazzling Illusions, Magical Mystery, Balloons, Fantastic Playthings, Crazy Cuisine, Down and Dirty. So actually, these are just general sort of science toys. Electronic devices, crystal growing, human biology, basic science, electric science, plant biology, chemistry, slippery slime. So only one of these is electronic and there's one that's electrical with a bulb. So this is not really a series of electronics products. What have we got? Battery information. Oh god, not again. Don't mix new and used batteries. Don't mix different types of batteries. I'm going to mix them. Here's the circuit diagram. So we've got a single transistor, the inductor, which is a 3-pin inductor, so center tapped or something like that, capacitor, resistor, 2 resistors actually, and a trigger wire which is directly across the piezo. Oh no. They've put the switch, that wire I assume gets pulled out. They've put the switch directly across the piezo. Also, what they're doing is they're shorting it out so that you can't hear anything. I assume this is an oscillator, an LCR active transistor oscillator, and it's running all the time, and they just short out the piezo so you can't hear it, and then when you pull out the shorting wire you can hear it. That's horrible. Maybe it's the easiest way of doing it. I mean, actually, if you think about it, it is, because you need an inverting function. You need that when you remove the wire, it switches on the sound. So shorting out the piezo, I suppose, is one option. There are probably other places, actually, you could put that wire to damp the oscillator down so that it doesn't oscillate. And then when you pull the wire out, it does start oscillating. I suppose that's an option, shorting the piezo. Yeah, why not? I wonder how much current it draws in its steady state with the piezo shorted out. Yeah, that's pretty nasty. Oh, here's an electrical circuit diagram. Yeah, again, you can see the short across the piezo there. Center tapped inductor, capacitor, transistor. I wonder what kind of oscillator that is. I'll have to have a look into that. And here is the device. So it's a base board with essentially little four-way, it looks like, sort of commoning metal pins in small groups. It's a really horrible layout. This string evidently is a tripwire, so we'll tie that to something on the other side of the room, and then when that wire gets pulled out, the oscillator switches on. This is all wired up, so someone's been playing with this. I wonder if I just stick batteries in here now. Obviously I'm going to put batteries of different types in here because, well, I don't want to play by the rules. So here we are. I'm going to put in one alkaline. This is a Class Olson alkaline. These were really cheap, 10 for £2. That's brilliant. And one rechargeable nickel metal hydride, so that I'm just not adhering to the instructions at all. That's not buzzing, which is interesting. I thought that would immediately start buzzing. What's wrong with the piezo then? Why is the oscillator not running? Oh, I'm going to have to fault find it now. So maybe the person who originally bought this took it down to the charity shop because they couldn't get it to work. One thing I've noticed is I can't really tell which is the center tap pin on this inductor. I wonder if the instructions tell you that, because it's a center tapped inductor. So this is just triangular. It doesn't really give any information away on where the center tap is. So I suppose I could try it in 3 different orientations. Now this should oscillate without the tripwire in it. But it's not that one. Is it this one? No, it's not that one. And is it this one? No, I can't get this to oscillate. I've spotted one thing. Some numpty has put the transistor in the wrong way around. You've got the flat facing the bottom of the unit there, and they've put it in with the flat facing the top. So that's got to be switched round. That's got to be re-bent. Ugh. I don't know. Give a job to people who don't know what they're doing. Right, let's re-bend that. Shove that in the correct way round. Oh, it still doesn't oscillate. Damn it! Actually, it does oscillate. If you sort of whack it a bit. These commoning... It did oscillate. Just... Oh yeah, there it goes. Yay! Burglar alarm. It's not very loud. I don't think a burglar's really going to be particularly bothered by that. But it is oscillating. I must have got lucky with this inductor then. Let's try flipping that round. Putting it in the wrong way. No, that won't oscillate. Flip it around again. No. And finally a third time. And it oscillates. That's bad, isn't it? So how do you tell which way around the inductor's supposed to go? Yeah, actually there is an instruction here. Put the short pin in socket 20. Short pin in socket 20. God, this thing got really loud. What is that? Oh. There's some really bad connections in here. Because the oscillator is... It's a musical organ! Fantastic, I love this. Now here's a bit of science. I was just whistling while I was reading the instructions, and I was getting some interesting beat frequencies. Can't whistle that high. I'll change the frequency, that's the answer. It's not working now. Bad science. Well, I've just shut the thing up because it was getting on my nerves, and I've shut it up by shorting out the piezo. But I wonder if there's other ways we could do that. I wonder if we could short the base of the transistor to its own emitter. I mean, that should shut it up, shouldn't it? Where's the circuit? I'll need to work out... Oh, it's a 2N3904. I should know where the base and the emitter are, but I don't, so I'm going to have to look it up. Actually, I won't look it up. Emitter goes to negative of battery. So, oh yes, that's that one. And that's the way around that it is. So it's the left pin. Yeah, that's negative battery. Oh God. And the base goes to 100k and cap. Yes, that's right. So the base is the middle one. Should have known that. Yeah, that shuts it up. But does it... I mean, maybe that would draw more current than just shorting out the piezo. I'd have to think about that to know whether that was in fact the case. But that just takes out the active element of the oscillator circuit and stops it functioning. And that is as effective a thing to shut the thing up as shorting out the piezo, which just seems wrong to me. I mean, actually, collector and emitter shorted would also shut this thing up, but that would put 3 volts directly through half of the inductor to ground. So yeah, that's probably not a brilliant idea. Shorting base, you see, is not really a problem because you've got 100k here to pos 3 volts. When there's no oscillation, that cap does nothing. So you're really putting a tiny current continuously through the system. But if I short collector and emitter, I'm putting potentially quite a large current directly through that inductor. In fact, with decent batteries, I could even possibly melt the inductor. So I think shorting collector and emitter is a bad idea. In fact, shorting the piezo is not a brilliant idea anyway, because you're some way away from... Actually, no, that doesn't make sense. Scrap that shot. Now, I don't know whether you can hear this. I can only just hear it, but shorting the piezo out isn't totally effective because there is a tiny bit of breakthrough still coming through. I'll just put that by the mic. I'm not sure whether that will come through, but there is a tiny bit of breakthrough still because, well, we're shorting the piezo, not 100% effectively because of poor connections in these connections. So probably you're better off shorting base and emitter. Oh, I don't need to short it now because something's gone so badly wrong. Oh God, this is awful, isn't it? Basically, these metal contacts are no longer springy enough to hold the wire. So yeah, I was saying short base and emitter. And there we are. So this is how you set your burglar alarm up. You put your burglar alarm, I don't know, on the wall. Put your trip wire, which is rather obviously white. I think someone could just step over that. Burglar trips on it, pulls that wire out, and hopefully this thing starts oscillating. Although, of course, there's every chance it won't, because the connections are so bad. These are really shocking. Look, a capacitor is a device that stores electricity i.e. builds up electricity and releases it only when there is enough stored up. That's absolute rubbish. That's not what happens at all. A transistor is a switching device. Think of it as a stopcock in the plumbing. When it is open, water will flow. If it is closed, there will be no flow. Well, that's not very good explanation either, because these things have linear regions. You can make it partially. Also, it doesn't explain how, people reading that might think you have to turn it or something to make it turn on and off. It says nothing about current flow base emitter and current flow collector emitter and gain and all that stuff. Piezo transducer. This is a big round metal disc. It makes noise when electricity goes through it. Actually, it doesn't. It only makes noise when there is a change of current, I suppose it would be, wouldn't it? In other words, you have to create an oscillation, which this oscillator does, in order for this to make noise. You'll get a click when you change the amount of current, I suppose, or electricity. Well, actually, potential across it possibly, because these things are essentially capacitors, I think, aren't they? So if you change the potential difference across it, you'll get a click, but you won't get a noise when electricity goes through it. This is utter rubbish. Who wrote this? This doesn't teach you anything. In fact, this is bad electronics. Bad. A resistor is a device that reduces the flow of electricity. You can also call them bad conductors. Electricity cannot move fast through resistors because there is high resistance that makes it hard for the electricity to flow. Now that's interesting that they talk about fast, because we always think about electricity flowing at the speed of light. So does a resistor make electricity flow at less than the speed of light? It's awful, isn't it? I mean, I wouldn't recommend anyone who wants to learn about electronics, well, certainly buy this and make it work, but don't read this garbage. It's nonsense. Now, I've just been looking up oscillators, the oscillator used in this circuit, which is this tapped inductor, and I've got a feeling it might be a Hartley oscillator. It says here the Hartley oscillator is a particularly useful circuit for producing good quality sine wave signals in the RF range. Well, this certainly isn't RF, this is AF. It says the Hartley design can be recognized by its use of a tapped inductor, L1 and L2 in the figure. So this has a tapped inductor, although it doesn't look like it's quite center tapped. This may or may not be center tapped, we don't know, because this support information is so bad. And in Wikipedia it says the Hartley oscillator is an electronic oscillator circuit invented in 1915 by American engineer Ralph Hartley. Now, of course, in 1915 there were no transistors, so the Hartley oscillator would have come into being as a valve-based circuit, a tube-based circuit. We've got a transistor sort of version of it, but yeah, that's old, isn't it? Yeah, this is the original patent drawing, which is quite interesting. You've got the two inductors here, one here, and a capacitor between the two, I believe. Yes, they're actually connected together at this end. So this is the center tap. This is a very interesting drawing of a valve, not the typical valve diagram, but you've got the heated or the powered heater here, small battery there to heat the heater, and then presumably one of these is cathode and anode. Don't know much about valves myself, but yeah, it's a nice old drawing, and it looks like the output is being, oh, I don't know, maybe the output's here, but I'm not sure what this transformer tap is for. I suppose I should read on. Now, can I change the frequency of oscillation of this thing by changing this resistor, the current flowing to the base? So this is some sort of bias thing. Not sure that's going to affect it very much, but let's try. I've got another 100k here, and I'll put it in parallel with this 100k. Oh god. Well, it does a fair bit. That's gone up at least an octave, or possibly two. Yeah, so you can alter the frequency. I probably can't see what I'm doing very well there. And there are other factors altering the frequency more than this, or almost as much as this resistor is. Yeah, it's not easy to do, but yeah, so we can vary the frequency of oscillation of this thing by changing this bias resistor, this pull-up 100k resistor, which pulls the base up to plus 3 volts. And similarly, we should be able to alter the frequency by changing this capacitor. Now this is 0.047 microfarads, that's 47N. That's very tiny capacitor for a 47N. Anyway, I found a 100N here, polyester. So let's pop that across. Ooh. Oh yes, nice low frequency, or set of frequencies. That sounds like some sort of Far Eastern or Middle Eastern musical instrument, like a bouzouki, or what's that thing? I can't remember what it's called now. One of those strange wind instruments that is tuned to a non-Western tuning scale. Fantastic. And I really like the way you just have to flex this thing to get changes in the sound. Oh, I love it. Really interesting that they've gone for an inductor-based oscillator than something like a 2-transistor oscillator that wouldn't have required an inductor. I would have thought an inductor would be more expensive than a transistor, so why not go for a 2-transistor design? It's really interesting. They've obviously tried to cut costs. Tried to cut costs as much as they can, because they've only fitted the metal shorting links in some of the receptacles here where you can put wires in, which is a bit of a swizz really, because otherwise you could use this base for sort of more complex designs, but they've not fitted these connecting links. You probably might be able to rob them out of a solderless breadboard, but they're only 4 holes wide. Most of the solderless breadboards are 5 holes long, aren't they? So that is a bit of a cheek. Yeah, shorting the piezo doesn't look like a brilliant idea to me, because you're shorting this oscillator will continue to run even with the piezo shorted. You're there putting a short through 510 ohms and through the transistor, which let's say is going to be on half the time. That's actually quite a low resistance loop, 510 ohms. I think my idea of shorting base to emitter, which is current flowing through a 100k, has got to be more efficient in terms of energy usage while the thing is switched off than shorting the piezo. Yes, I like my version. Now it's interesting, this thing, I said when I bought this at the charity shop that I would make a video on it and then I would throw it away, because my room is so cluttered I can't keep all this stuff, but I really like this and I'm not sure I can bring myself to throw it away, even with the atrocious science in this manual and the repeated banging on about don't mix batteries. Look, I've mixed batteries and it works perfectly well. And the fact that electronics is only a subset of what this crazy lab kit series is. Oh, it's another one of those things where I just can't throw it away. Cheerio.